Hi, this is Purnima Mahalingam, and you're watching video lecture series on solar and wind energy. And this topic, in this series, first we are going to see about the evolution of wind power and it's an overall historical review. In this PPT, we are going to discuss about the rich history of the power, examining significant development over the year. We will look into current scenario both within India and globally, along with the specific scientific principles that governs with wind energy. Key topics will include the bench limit, tip speed ratios, and pitch control, all of which are fundamental to understand the wind energy technologies. By tracing these evolutions, we aim to highlight that wind power critical role in today's energy landscape. Okay, come, let's go into the video. Now, come here, it is in a wind. Uh, so, history of wind energy. So, first, we can see that it's the early usage of wind. So, wind power has utilized since ancient civilizations, with the first usage of windmills in Persia in 500 to 900 BC AD for graining and water pumping. This is what in history. First for graining and water pumping, and next one is industrial revolution. The second thing is industrial revolution. 18th and 19th century saw a decline in wind power, with rise of steam engines, but need for renewable energy resurfaced in 20th centuries due to the fossil fuel contents. Okay, so next one is modern wind turbine. This is in the modern wind turbines. The later 20th centuries mark the beginning of modern wind turbines. So which improves the efficiency, and leading the large scale wind farm in 1980s. Large scale wind farm is primarily in US and Denmark. This is the timeline of wind power. This timeline history of wind power. So now coming to the globally. So globally, what happens? It is 50% of global wind production, wind energy capacity. There are 50 more than 50, over 50% is occupied by the China alone, and in as of 2023, So wind power in India, it is 40 gigawatts, almost 40 gigawatts. It's an aim of 60 gigawatts by 2022 and 140 gigawatts by 2030. Okay, this is what I'm economic, and it is an economic benefits is thousands of jobs. So economic benefits is the wind sector has generated thousands of jobs in manufacturing and installing and maintaining. So in this field, in manufacturing field, in installing field and maintenance field, we have thousands of jobs were created with the help of wind energy sectors. Now coming to the physics, wind physics. So here wind physics, we are talking about wind physics. Wind physics is understanding the wind energy. First one is what we are understanding the wind energy and whatever aerodynamic of wind turbine and energy conservation. Main thing is understanding the wind energy and aerodynamic of wind turbine and energy conservation process. So in energy conservation process, we know the mechanical energy generated by the wind turbine blades is converted to the electrical energy. That we have known that mechanical energy is converted to the electrical energy through a generator, and we have a gearbox and converters. This is what energy conservation process. The aerodynamic with the process of force, dragging force, etc. And wind energy is the kinetic energy of a moving of an air. So small increase in wind speed can lead to the sustainable energy production. This is what in basic wind speed. Now coming to the understanding the bench limit. What is in bench limit is indicates that the no turbine can capture more than 59.3% of wind energy. This is what in wind definitions. And the impact of this impact in wind turbine design is engineers use bench limit to enhance the turbine design for high efficiency. And the real world turbine efficiency is actual efficiency large ranges from 35% to 45% due to various factors. This is what real world wind turbine efficiency. Now coming to the tip speed ratio. That is first one is definition. What is tip speed ratio definition is that tip speed ratio definition is first thing is ratio of blade speed to the wind speed crucial for turbine performance. This is what definition of wind speed. And this next one is optimal speed. Next one is optimal speed. The optimal TSR for horizontal axis wind turbine typically ranges from 6 to 10 for maximum energy extractions. And control mechanism. So modern turbine uses control system to adjust the blade pitch and rotor speed and maintenance and optimal tip speed ratio. This is what an tip speed ratio, understanding of tip speed ratio. Next one is star control. Here plays an important role, stall and pitch control. So over the stall control is the passive method of regulating energy capture at high speed, and pitch control mechanisms adjust of blade angle. So adjusting the blade angle to optimally perform across the various conditions. And stall control, simple and cost effective. Pitch control is more efficient for long turbine. This is a comparative advantages. This is what stall and pitch control. And future of wind turbine is the aspect of three main things. One is technology involvements, innovations, and integrated with other renewables, and global privacy and investment. These are the features of wind power. Uh, finally, concluding it is with the three part. One is signification of wind power. Next one is sustainable solutions and call of actions. These are the main three parts of concluding the wind energy. So thank you so much for watching this video. We'll meet you with another topic. Thank you so much. Bye bye.